Hello there. There are many questions students ask when they're learning calculus or any sort of math. The main question they ask though is, how do I use this in the real world? Well, I'll show you.
For example, chemists calculating the half-life of radioactive substances after their radioactive decay. Come, let me show you. So here we have a question asking the half-life of a radioactive substance. Now, this is a formula given for this specific substance. Pt equals to 500 bracket 1.5 to the power negative t. Okay, so let me break this down for you first. This is the percent. This is the initial amount. This is the constant value. Now remember, this constant value is for the specific substance only, okay? And now this is the half-life. Okay, so pause the video first before I teach you how to do it. Okay, so now let's look at the clues here. They're asking for half-life, and we know this is written in percentage. So, and let's assume that this amount is 100% of the radioactive substance. So by right, this should be 50 equals to 500 1.5 to the power negative t. Now let's just simplify, divide 50 by 500. So we get 0.1, 1.5 to the power negative t. Okay, so now let's use ln. Okay, since we have unknown power, let's use ln to make things easier a little bit. Ln 0.1 equals to negative t ln 1.5. Okay, so now it's a little bit more simple. Negative t ln 0.1 ln 1.5. So negative t would be equal to negative 5.68. Switch it around a bit. T is equal to 5.68. So let's write that down properly. Answer. Okay. Half-life of substance is T equals to 5.68 years. Don't forget the units. Another form when we use calculus in the real world is when we have velocity and we want to find acceleration. Usually people think they have to have a new formula, having time and everything, but actually if we have the equation of the velocity, it's a lot easier to find acceleration when you know calculus. Okay, so here we have a question asking to determine the acceleration of an object at 3 seconds when the position function is 5t over t plus 6. So the basic rule is, if we derive the position function, we get the velocity function. If you derive the position function twice, we get the acceleration function. Okay, so let's look at this. We have one unknown in the numerator and one unknown in the denominator. That means we have to use the quotient rule. So let's just do a quick recap. F prime times g minus fg prime over g squared. Okay, so let's do that. So that's basically 5 times t plus 6 minus 5t and 1 over t plus 6 squared. So let's just do that real quickly. Minus 5t t plus 6 squared. So basically the velocity function, if we simplify it, would be 30 over t plus 6 squared. Okay, so now we have to derive it one more time to get the acceleration function. Now we cannot use the quotient rule because there's only the unknowns only in the denominator. What we can do is the power rule. We can move this denominator up top, and then we make the power sign negative. So let's just rewrite that. We're not deriving just yet. We're just going to rewrite it. Let's put 30. Let's make a dot to show that it's going to be multiplied. And t plus 6 and negative 2. Okay? So now let's start to derive it. We're going to leave 30 untouched first. Okay? We'll put that there. We bring it to the front. Negative 2 times t plus 6. Then we minus that, so it'll be negative 3. Now, as you know, for the power rule, we have to derive inside the bracket. But if we just derive inside the bracket here, it's just going to give us 1. It'll basically make no difference. So let's simplify it. Negative 60 t plus 6 to the power of negative 3. This way is correct. You can write it this way, it's up to you. But I want to make it a little bit more neater. So it's going to be negative 60. And because the negative power basically means it is the denominator. So we move it down over there. T plus 6 power 3. Okay, so now we got the acceleration function. We're not done just yet. We should sub this 3 seconds into this function to determine the acceleration of the object. So negative 60 over 3 plus 6, 3. Okay, so after we key in our calculator, we should get negative 0.28 meters per second squared as our acceleration. This should be the answer.